In the last session, we left off with our mobile game service having just suffered an outage that wasn't captured by the SLIs we set for it. If you recall our discussion of the pros and cons of different measurement strategies in Module 3, one of the major drawbacks of measuring success in your front-end infrastructure is that you only have access to the protocol metadata at this point. If that metadata does not reflect the true state of the response, then your SLI could be lying to you. Hopefully the exercise has highlighted how important the third step of a process is. If you don't walk your user journey and consider what your chosen measurement strategy will observe in your SLI metrics, when the infrastructure fails, you put yourself at risk of running into gaps like these, and having to write your own postmortems. The way we've chosen to close the observability gap identified in the postmortem is to augment the load balancer metrics with a black box prober that can inspect and verify the response body. But this is by no means the only way. The prober also validates that our front-end infrastructure is doing the right thing with the request routing and tests that our CDN is serving content correctly, the other two gaps in the previous SLI. While we've not chosen to measure a latency SLI with the prober, doing so would be easy. We avoided this because unless we run our prober in multiple disparate places far removed from our infrastructure, think pingdom, it's a strictly worse measure than the one derived from the load balancer metrics, which covers all the user requests rather than just those made by the prober. This is also why we chose to augment the previous availability SLI rather than to replace it. When we're walking our user journey and considering the failure modes of our infrastructure, we're trying to answer three questions. First, do the SLIs adequately capture the user journey and its failure modes? Are there any exceptions or edge cases to consider? And finally, do the SLIs capture multiple journeys with differing requirements? We say adequately capture because reaching 100% coverage of all possible failure modes is once again the wrong target. Firstly, distributed systems fail in complex and surprising ways, so 100% is often an unrealistic goal. If the failure mode is sufficiently rare that it won't eat more than a fraction of your error budget, then it's reasonable to argue that it's safe for your SLIs not to capture it. Failure modes that are outside of your control and that your users are unlikely to blame you for are best left out of your SLIs, although having some observability of them can still be valuable. Things like failures at consumer ISPs or mobile phone carriers would fall into this bucket. You can't do too much about them, but in some cases it can be useful for your support teams to know that they happened. Lastly, you have to perform some form of cost-benefit analysis. In some cases, extending your SLI to cover a particular failure mode could cost months of engineering effort and require re-architecting your service, your monitoring systems, or both. Building detailed client-side instrumentation from scratch can be expensive, for example. You may instead choose to document that the SLI does not capture that particular failure mode and put in simpler things to detect and mitigate it. We'll need to keep these things in mind in the next video as we walk through our user journey and analyze how the infrastructure serving it might fail.